Welcome back, my favorite Python programmers, to a brand new video, and in this one we're tackling one of the biggest challenges in our farm. If you don't know, The Farmer Was Replaced is a game that teaches you how to become a master Python coder by using a drone to farm a farm. And today we're turning weak pumpkin farming into a super efficient mega pumpkin factory. This is going to be the key to unlocking faster cacti farming, and I've got some very powerful tools and tricks to make that happen. And before we get started, I want to tell you something that's very important about this video. This is going to be different than previous videos that I've done in the series. Instead of just me going through this entire code, I want you to be coding along with me. I'm going to be leaving all of the Python files down in the description so that you can download them and start from where I am right now. I'm also going to be having challenges throughout this video, so you'll have to be pausing, trying to do the challenges, then coming back, seeing the solution that I came up with. Maybe you can come up with a better solution, so keep that in mind as you're going through the code. So let's go ahead and dive in. First thing we need to figure out is going to be how to optimize our pumpkin farming. This is going to help us a lot in unlocking our speed upgrade, which will first of all need us to unlock the cactus. So as you can see, the cacti need 4K pumpkins, which means that we are going to require a lot more optimized pumpkin farming. The problem with pumpkin farming, we already have this pumpkin thing happening right here. Let me show you what we've had up to this point. So as you can see, we have all of these pumpkins coming out, but as you can see, some of them are dying, which is not good. Our goal, so I'm going to stop this right here. So as you can see, some of the pumpkins form bigger pumpkins together, and this is what we ultimately need. So if I go right here, I'm going to show you that in the pumpkins, they have a 20% chance of dying. And you can see right here that we can actually create one giant pumpkin, and that is going to be the goal of this video. Right here, as you can see, we have this farm, which is not very efficient. My goal is to make one huge giant pumpkin. And to do that, I've thought of several possible ways that we can plant the pumpkin and, well, first of all, plant the pumpkins just as you see them right here, and then go through the entire field again and check which squares have empty slots and then plant the pumpkin there again. And we keep planting these empty slots until all of the pumpkins or all of the regions are planted, and then we can finally extract the one huge pumpkin. So let's go ahead and create a new Python file. And in here, I'm going to call this the mega pumpkin, right? I'm going to zoom in a bit and I'm going to start coding. So first things first is I want to set the world size, because this is what we've been doing all the time. We're going through double loops, which will allow us to go first of all through the columns and then the rows. So I'm going to simply copy this while true, or actually, let me just copy this, because we're going to actually be introducing a lot more modularity. We're going to be focusing a lot on functions this time around. But as you can see, we're always using the get world size. This is a function that's being called, which is taking resources. So instead, I want to create a variable that is going to be the world size, and it's going to be equal to get underscore world size, right? So now I can replace these world size. It's not allowing me. I'll just copy and paste, because we are coders. We copy and paste. We do not write things from scratch, especially when they are not giving me sufficient suggestions. Also, I'm going to put this in the initial planting. So as I told you, the way I want to go about this is I want to first of all create or plant all of my pumpkins right in this field, so it looks something similar to this, where I have, like, for example, in this case, 1, 2, 3, 4, 5, 6, 7, 8. So 8 missing pumpkins. So I'm going to plant everything, so nothing is going to be different. It's giving me an error because I haven't done anything inside. So in this case, I'm going to, first of all, make sure I have extra indentations, I believe. Let me just make sure that there are no problems with the indentations. All right. So first of all, we know that pumpkins need to have soil. So first, I'm going to have to till the ground. For that, I'm going to check the ground type. And if it's different than grounds.soil, then I'm going to till the ground. So it becomes soil and we can actually plant on them. Once it's tilled, I'm going to plant entities.pumpkin. Now, keep in mind, pumpkins require carrots, so I'm going to have to run this game for a bit to then have it working correctly. And then I'm going to move north, right? And after I've finished up with planting all of the columns, remember, so I'm planting a pumpkin and I'm moving north. I'm planting a pumpkin, moving north. And once I'm done with all of the columns, I move north one more time, and then I'm going to move east, right? So this is going to be the initial planting, and I'm going to be testing out the code throughout this. First things first, I'm going to take a small break, and I'll come back to you once I've managed to get a few more carrots. Hey, welcome back. So as you can see, I've used up all of my wood and all of my hay to make sure that I have all the necessary carrots, or as much as I possibly can. But I think this is going to be enough to start testing. So this is going to be the initial planting. So we're doing things a little bit different than what we've done before, because this time, instead of just having this code immediately, I've created a function using the def keyword, and then I have created this following code that will allow us to plant at least things initially. So I'm going to clear right here to get back to the start, and I'm going to run this code, and you'll see that we will plant our initial pumpkins. So as you can see, many of the tiles are planted, and the drone stops right here. The next step is going to be going through this plot of land again and replanting the empty slots. And this time, this is what I wanted to do differently in this video, and I'm going to present you with a challenge. So your challenge is going to be to replant the missing pumpkins. I want you to create a new function that's going to be replanting. It's going to be in the same file as the mega pumpkin. I want you to loop through all the tiles in the farm using the nested loops. So we've already done that. Check if there's no entity on the tile using the get entity type. So as you can see, I'm giving you a lot of hints here. So you need to first check, is there a pumpkin on that tile? And if not, if empty, plant a pumpkin in that tile. Move north after each tile, move east at the end of each row. Keep in mind, because once we finish, we need to go back and then check again. And I have a hint for you. Now, if you don't want the hint, you can pause the video right now and go do the challenge. But if you feel like you're unsure of what's gonna happen, you need that extra help, then I highly recommend that you check the hint, which is going to be to use not get entity type to check for an empty tile. Because remember, if get entity type doesn't have anything on it, it will return none, and none is considered false when working with an if. All of these Python lessons, you can check them out. I've already taught you in various videos. So I highly recommend you pause the video, you try to do it on your own. Files are in the description. You don't have to do it correctly all the time, but if you try and then you see the solution, it will be much more helpful to you. Hey, welcome back. So how did you get on with that challenge? I want to now create the replanting. So as I've said, there are a few things that we need to do. First of all, we will define the replanting, right? So this is going to be our new function right here. We've defined the replanting, and I'm simply going to copy this nested loop because, well, this is what we were doing all the time. And by the way, world size, as you can see, is on the outside. So this is variable scope. It's on the outside of all of our functions, which means that we can use it in any functions that we want. So now that we've got right here, we're going through each individual tile, and we're going to check if not get entity type. So remember, get entity type returns, let me hover over it. So get entity type finds out what kind of entity is under the drone and returns none if the tile is empty, otherwise returns that type. So whenever it returns none, none is considered a false. This is something that I always teach my students, so you should know that if you watched my previous videos. If you haven't, then I recommend that you do. We return none, which is a false. So what we do is we check if not none, which is if not false, which means the ground is empty. So this is false. Not none becomes true. So I'm going to print out, or I'm going to plant. I'm just always used to printing things out. I'm going to plant entities dot pumpkin. Boom. By the way, if you have any other questions, you can always let me know in the comments below. If you have any questions for that matter, leave them. You can leave timestamps as well so that I know exactly what to answer you. So obviously, we're going through for I, for J, so we're going through all the columns and rows. We're checking if the entity is not. If it is none, then we're going to be planting. Because this might be confusing. If you have any questions about this, please leave them in the comments below. I will help you with that. Basically, if it's empty, we're planting the pumpkin. After we do, we're moving north. Keep in mind, we don't move north only if we're planting. We're moving north regardless, because this condition might not work and we might not plant the pumpkin. We move north, and then at the end, once we finish with the J's, notice the indentation. It's this move is for the outer for loop. We move east, and after the initial planting, we're going to be calling the replanting function. Don't worry if you didn't get it the first time, that's not a problem. Right now, I'm going to clear this again, because keep in mind, if I run this from again, it's gonna start the initial planting again. So I'm going to just clear and start ahead. So notice how everything is happening with the initial planting. Once the initial planting stops, we're going to go back to the planting. All right. Boom, there we go. How cool is that? As you can see, a few things did work out right here. So we've planted some of the pumpkins, but there are still a lot of missing pumpkins. So in that case, I would call the replanting again, right? It makes sense. So this time I'm gonna reset, I'm going to run again, and let's see what happens. Hey, look at that. So now we have our mega pumpkin working. Now, of course, there are a few problems that we're not harvesting the pumpkins, and also we don't want to harvest unless every single pumpkin was laid and we have a mega pumpkin. So what I was thinking is we need to, as we are replanting, we need to keep count of how many things we've actually, or how many plots of land we've actually replanted, because if we haven't replanted all of them, we don't want to harvest. We only want to replant once the number, we only want to harvest once we have not replanted a single plot of land. So I want you to think about it for a moment. Try to think of what we can do. What does it mean for us to keep count of how many things or how many plots we've planted again? That means we have to create a counter. And inside of the replanting, I'm going to create the plant number variable, and I'm going to set it to 0. So every single time we are calling the replanting, we are setting this counter to 0 to see how many times we're actually going to plant. And right here, every single time we plant a pumpkin, we're going to say that the plant number, let me just copy it because again, I'm lazy. And I'm going to say plus equals 1. So basically what's happening is every single time we're calling the replanting, because we don't know how many times we're going to be replanting. I mean, I did it twice right here and it worked. We got our big pumpkin. Now we can harvest, right? But what if it takes us 3 times? What if we expand our farm a lot and then we need to replant it 5 times? We don't know. And we don't want to be replanting more than we need, correct? So this is what we're going to do. We're going to be counting the number of times that we've planted a pumpkin, and if that number is greater than 0, remember, 0 means we haven't planted a single pumpkin again, or we haven't replanted a single pumpkin again, which means we can start harvesting. And we will need to return this value. Why? Because, so plant number, and the reason why we need to return this variable or this value, because this variable belongs only to the replanting function. It cannot be used outside of it, so we need to actually return it. Now, how do I handle things on the outside? This is also something for you to handle. So what I'm going to do is I'm going to create a variable right here, which is going to be a value that I'll explain once I have actually created it. Let me just give it. So I'm going to call the empty slots, right? I'm going to say that the empty slots is equal to the world size to the power 2. Why am I doing this? And by the way, whenever we have two multiplication symbols, it means that it's to the power of 2. And why do I want to do this? It's because it's taking the highest possible number of empty slots, which means that if none of the pumpkins survive, I'm going to have empty slots that are equal to the world size to the power of 2, because world size, if I multiply this by this, I get the total number of squares that I have, correct? And then I'm going to say, after the initial planting, while empty slots is different than 0, I'm going to be replanting. But not only that, remember, when working with a while loop, we need to initialize the condition on the outside, and that condition needs to be changed inside. So I'm going to say empty slots is equal to replanting. And remember, replanting is returning this value. So we're calling the function, we're doing all of these, and then we're returning the value into the empty slots, which gets updated and then checks. Have we finished? Have we has our empty slots different than 0, which means we will keep doing this while the empty slots are different than 0. Every single time, if we plant a pumpkin, it's returned into the empty slots. The empty slots were 1, which means we have to redo it. So after we finish, we will harvest. And this code should be working. Again, any questions, please leave them in the comment below. I'm going to hit main. I know we're gonna lose this pumpkin right here, but it's okay. This is for experimentation. And I'm going to hit the run. Hey, look at that. Boom! And as you can see, we have harvested 1 mega pumpkin. It did work. As you can see, I've probably sped up the video, but this pumpkin right here took us like 2 or 3 times. We always had to go back and recheck it. Now, this is not a perfect code. Why? Because we're always going back through all of the empty slots. I would like to later on make it better, but for now, this seems perfect. This is so much more efficient. I'm going to wrap all of this in a while true so that we keep doing this all the time. I will reset this and I'm going to start farming mega pumpkins. I will speed up the video for you now, but I want you to take the time to understand how all of this is working. Hey, something that I noticed was that sometimes the pumpkins don't have time to grow and fully become like one huge pumpkin because of the speed of our drone. What I was thinking was maybe I could do something to just slow the drone down, and I have the perfect solution. What I want to do is right here, I want to print out the empty slots. That way, we can also use this for debugging. So I'm going to reset, even though we don't have too many carrots left, but still, look at what will happen. All right, so notice what's gonna happen right now. The drone comes here and prints out 9. So there were 9 replantings happening. 2 replantings happening, boom, 1 mega pumpkin, 1 replanting. So you can see that our system is not entirely perfect. The reason for this is because the drone has to go back and recheck everything before it harvests. Not the ideal situation, probably can be fixed later on. We can add a list that keeps track of all the places where we harvested or where we replanted so that we can go back and check. And this can be an awesome challenge for you to do on the side. But for now, we have all of our pumpkins. I'm going to stop the mega pumpkins right now. I am going to, because I want to reset and I want to get some wood while I unlock the cacti. But before I do that, remember the woods, the trees were taking a little bit of time, so I'm going to be importing the watering. Again, if you don't remember what this was, I highly recommend that you watch the previous video where we have actually done this. So harvest, after we've harvested, we're going to plant, and I'm going to be planting a lot of wood because I'm going to need a lot of wood to make a lot of carrots, to make a lot of other things. But anyway, let's go ahead and unlock cactuses. If we scroll up, I'm going to look right here, because why do I want to unlock cactuses today? Because I want to upgrade the speed, and because cactuses will have a very, very interesting things to do. Cactus unlock. Boom. As you can see, our trees are being handled in the background. Meanwhile, let's check what cactuses are. Now, what I did is I actually went through this before doing this video, and this one I was a lot more prepared because I've had comments like, hey, how about you remove some of the things that you're doing? I mean, okay, I did what was asked of me. What I did is I compiled a list of things that you need to know about cactuses. Alright, so what is cactus harvesting mechanics? First of all, cacti grow on soil. By the way, if you don't want to watch me talking about all of this, this is how I teach classes. This is a literal class, even though we're playing a game. I recommend that you just read all about it on your own and you try to figure things out for yourself. So, cacti grow on soil, just like pumpkins, and can be harvested. It also requires 2 pumpkins. So, for every cacti, we need 2 pumpkins. That's why I wanted to make sure that our pumpkin harvesting is optimized. If you harvest a fully grown cactus and all its neighbors follow a specific sorted order, the harvest spreads recursively. And recursively meaning the game will do the rest of the harvesting for us without moving the jaw. So the cactus present a new mechanic where you can harvest several cacti by simply harvesting one of them, if they are in a sorted order. So let's see. What does this sorted order mean? It means that north and east neighbors must be larger or equal in size. So you'll see that the cacti have different sizes. So the north and east should have larger or equal sizes, and the south and west neighbors should be smaller or equal. We're going to see an example of that, but before we do that, let's see if a fully grown patch is in sorted order, harvesting one cactus clears the entire patch. You gain n to the power of 2 cactus items when n cacti are harvested at once, which means, just like pumpkins, it's much more beneficial to have them all together. So we're going to figure out what this sorted thing looks like, because we will want to harvest them when they are sorted, where we have the north and east being bigger cactuses and the southern and western being smaller. You can measure cactuses' size, they are numbered 0 to 9, with the function measure direction, and swap cacti with neighbors to adjust the order with the swap direction. So as you can see, we are presented with a lot more mechanics, where the cactuses have different sizes, where we can measure the direction, and where we can actually swap directions. So let me go back right here. So we have this cacti. It cannot be upgraded unless we have this, and we are getting a lot of wood. I want to... what should I do with the wood? For now, I don't want to do anything. I have tons and tons of wood. What I do want to do is I want to stop the wood because I have enough, and I want to start probably farming carrots. Let's go ahead and start farming carrots. By the way, I've maxed out the yield of carrots. But anyway, let me go back to my farm, and I want to show you something that will help us understand things better. So as I told you, there is a sorted number, so cacti can have different sizes, and we can use the measure. By the way, I didn't create anything on my own. Everything that I made in the slides was from this, so you can definitely learn everything. And this is an example, okay? So in each of these grids, all the cacti are in sorted order, and the harvest will spread over the entire field. What does that mean? So that means if I harvest one of these 9 cacti right here, all of it will be harvested. Why? Because as you can see, if I take this number 1 right here, on the west, or sorry, on the east and north, we have 2 and 2, which are greater than or equal to. On the, if I take this 3, we have 4 and 4, which are greater than or equal to. If I select this one, for example, the 8, on the north, it has 9. So as you can see, these are all sorted, which means when I harvest one of them, the rest of the cacti get harvested. And remember, this is extremely beneficial because you will receive cactus equal to the number of harvested cacti squared. So the more cacti we harvest, the more cacti are sorted as we're harvesting, the more yield we get, which is how we should be doing things. I'm noticing that the hay is running low, so I'm going to in the meantime, I'm going to just keep it until the hay is done, and then I will start getting hay again to start making pumpkins. in the meantime. But anyway, for example, in this grid, only the lower left cactus is in sorted order, which is not enough for it to spread. So for example, right here, as you can see, we have 9. In the north, we have 5, which is not good. On the east, we have 7, not good. We have 4 and 3, which is acceptable. So what they mean is that this little square right here is good enough, because on the right or on the east of 3, we have 3, which is greater than or equal to. On the north, we have 4, which is greater than or equal to, and we have the 9 right here. Now, I have these 2 hints. I will want to show them to you. Hint number 1, if every column and every row on the field is sorted, then the entire field is sorted. So, notice how rows and columns are sorted. So this is going to be a huge and massive indication to us, because I will want to use a sorting algorithm that I'll show you in just a bit to first of all sort out the entire columns, then go back and sort out the rows. Pause, clear, start farming hay. And hay or grass, is that hay? Yes, so put up grass. I want to increase the yield of grass as well once we have 11k. The second hint, if you're not familiar with sorting algorithms, you want to look them up online and find them. I highly recommend that you actually do that. But in the meantime, what I want to do is I want to set this mega pumpkin farming aside. We will need it later on because we will be creating cactuses, and I will want to create a new Python file that's going to be cactus farming. And I'll want to do just a few cactus farming right here, just to see what it looks like, to show you what it looks like. So as always, I'm going to create the world size equal to get world size. Then I will create the 2 nested loops, or maybe this is called the 1 nested loop. Boom, right here. And I'm going to use the variable get world size, and we have extra indentations right here. It's okay. And first of all, I'm going to check if I can harvest. I'm going to harvest, right, just to make sure that everything is harvested. Then I'm going to say if the get ground type is not equal to ground.soil, because remember, we can only plant cactus in soil, we will till, and we will plant entities dot cactus, right? And then once we're done, this is very typical. We've been doing this for a very long time, where once we're done with the planting, we move north, then we move east when we're done with the column. Okay, perfect. So I'm going to also call this, we're not creating a function, sorry. So I'm going to reset this, get back to the start, and run this one time. We get an error because the ground type is a function that we call. Let's do this again. All right, so as you can see, cactuses grow really fast, even in dry ground, which means that we don't need any water or any fertilizer, and we have different sizes. I can't really discern the size. I mean, some of them are obvious. You can see this one is the smallest, this one is bigger. Anyway, we don't care because we have programs that will allow us to check them. So once we've planted all of our cactuses, what I want to do next is, I mean, we can just start harvesting them right off the bat, right? I mean, that is possible. If I run this again, look at that, I'm harvesting and now I'm getting my cacti, but as you can see, it's not efficient because I'm harvesting them one by one. We got 36, not enough. We want one huge explosion of cactus harvesting, which means we need to be sorting these. So I'm going to do something that's very similar to what we've done before. I'm going to create the initial planting, right? And for some reason it gave me the suggestion for the name. So this is going to be the initial planting. I forgot the columns, which will basically do exactly what we were doing right here and just plant cacti at the start. Next, let's talk about the sorting that we're going to be doing. And as I told you, I want to be sorting columns and then I want to be sorting rows, which will make things much easier for you to understand. Of course, we can do that in one go, but I want to take it step by step. This is the exact row and column that we have previously. So let's say this is our cactus distribution. We have 3, 9, 3, 5, 1, 4, 1, 3, whatever. If we sort out the columns, you can see that now we have 1, 3, 4, right? We had 3, 4, 1. Now we have 1, 3, 4. Right here we have 3, 5, 9. And then we have 1, 2, 3. This is when we sorted out the columns. Then we'll go back and we will sort the rows. So we start right here. So 1, 3, 1. It becomes 1, 1, 3. Right here we had 3, 5, 2. It becomes 2, 5, 2, 3, 5. And the 4, 9, 3 becomes 3, 4, 9. And as you can see, now we have this sorted columns and rows. And this is what we are going to try to do with our cacti. So, as we've said, we have two functions at our disposal. We have the measure direction, which will allow us to check, or actually let me take you back to the farm. You can pass the direction into the measure direction, which will allow us to measure the neighboring tile in that direction. So we will be able to check the cactus in the direction that we want. It's gonna be the north when we're trying to solve the columns, right? So we'll check in the north, is the cacti in the north bigger or smaller than the one that we're on right now? If it is, we're going to use the swap. And we can also send in the direction where we want to swap. So swaps the object under the drone with the object one tile in the direction of the drone. Let's go ahead and do this. I've put the drone to planting, as you can see, because we will require a lot of pumpkins as we are experimenting and trying to figure out like what's working and what's not. So 0, boom, gets it done. I mean, this is amazing. This is very nice. We will need to optimize it. You can optimize it on your own, but now after we've done our initial planting, we will want to define the sort cactus column, right? Or columns. So I'm going to say for I in range the world size, for j in range world size, if we are going to measure what's in the north, if the measure, I'm not getting the measure, direction, I'm not getting the measure, which is worrying. If the measure is greater than measure, because remember, if it's equal to, we don't want. And measure without any direction will probably measure the current cactus we're on. I'm going to swap north. Wait, what happened? I'm going to swap north. Yes, there we go. And after I'm done, I'm going to move north. All right. Seems like it should be working, but before I start doing it, I don't want to experiment on the entire field, right? So I just want to be experimenting on just one column for now, trying to figure if things work out on that column and then move ahead. By the way, something that's very important right here, these I and J don't actually represent the entire thing right here, and I'll show you what I mean by that. Because right now what we're doing is we're using something called a bubble sort, and I'm going to show you how this bubble sort works like in the real world. But before I do that, I want to create a testing plant. So I want to be testing the planting. So I will define a function right here. I'm just going to copy what I have right here. I'll show you what this does. I will call this test planting. And instead of doing the entire for I and then for j, I just want to plant a single column. So I'm just going to remove the I right here, right? And then I'll have to do this manually. It's a bit of a pain in the butt, but there we go. So now we are going to only plant a single row, a single column. And at the bottom of all these functions, I'm going to first of all test planting, which will plant a single row. And then I'm going to sort cactus column. Okay. Let me just wait for this last one. Okay, 0, boom, harvest. All right, you can stop. So we have a lot of pumpkins, 28,000. Let's go ahead and plant this cactus. So look at what's gonna happen right now. I'm gonna run, boom, 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 boom. And I have an error because direction has never been defined. Direction has never been defined. Did I just say direction? Am I stupid? I am stupid, I don't know. That's a huge mistake. Anyway, perfect. No harm, no foul. We reset. We run again. Unlocks.maze must be unlocked. So that's what I suspected, that the measure. Yeah, when I typed in measure and I didn't get the suggestion, it threw me off. That's why I wrote direction. I mean, that's no excuse. I'm just kind of dumb. But apparently the measure is in the mazes, so let's go ahead and unlock the mazes, which requires 3k pumpkins. We have that. Okay, look, I'm not gonna think too much about mazes. I'll leave that for the next video. Right now, we need to handle, oh my god, looks like mazes are gonna be very hard. That's good. We clear, we run again. So we test the planting, and boom, as you can see, look at that. They were sorted, but in the wrong way because, yeah, oh, so if we're measuring north, yeah, it has to be the other way around. Because if our current measurement is greater than the one in the north, then we'll swap, right? Because we want the biggest ones at the top, remember? Because of the following distribution. Notice, the biggest numbers are always on the top right corner. So that's why, let me just take this right here. Okay. Boom, there we go. And let me clear this, run again. And I want you to see how, look at that. Very, very nice. So all of our cacti were sorted. You can see right here to the naked eye, these two smaller ones, then a little bit bigger, a little bit bigger, bigger, and then we have the biggest one. Now, this is all fine and dandy, but I want to show you what's happening under the hood. And right here, I have an actual bubble sort simulator, which is gonna be very, very interesting. So I'm going to add the following array, and I'm going to show you how bubble sort actually works. So this is a bubble sort visualizer. So I'm going to run. Okay, perfect. Look at that. So let's imagine that instead of having these big numbers, right, we have the 1s and 9s and 7s and whatever. So we want to sort them. Look at how the bubble sort actually works. So the bubble sort, we start, I do recommend that you read all of this. I'm going to leave a link in the description for this. If you don't find the link, please leave a comment. If you have any questions, you can also leave a comment. So notice what's gonna happen. Okay, so we start with the first two numbers. So imagine these are the two cacti. This is the bigger cacti with a 64, and the next one, the one just next to it, is the 30. Actually, you know what? I think it's gonna be better if I do something like this. Run. Okay, so these are the sizes of my cacti. Okay, so we have a cacti of size 6, and the cacti that's north to it is of size 3. We swap them, right? So we've measured them in our code right here. So we measured them in our code right here. If the current measure is greater than the measure north, we are swapping, correct? Everything good so far. Then we compare the one that we're on right now. We move north, correct? So after we've made the swap, we move north. Our drone was right here on 0, it moved to 1, which was swapped previously. On cacti 6, we can measure, and the north, we swap. We move north, 6 and 1, we swap. We move north, 6 and 2, we swap. We move north, 6 and 1, we swap. We move north, 6 and 9, we don't swap. And notice what happens in the bubble sort is that every single time the greatest number is gonna be automatically sorted to the end at every iteration, right? So now we go back to the very start. 3 and 2, 3 and 1, boom. And automatically the second greatest, which is 6, gets sorted to the end. Let's do it again. 2 and 1. 2 and 2 are not swapped because remember, we said greater than or equal to. 2 and 1 and 3 is set. Now notice what was happening. Before, we need to go and check with every single one, but now we have these firmly in place, the 3, 6, and 9. So what I'll do, what will happen is that instead of iterating through this several times, we only need to check this with this one. So 1, I'm on the camera right now. This one and this one 1, this one and this one 2, this one and this one 3, and that's it. And we don't need to compare this and this one with 4. No, that's enough. 3 comparisons are enough because the greatest number will go. Let's see it in action. 1, 2, 3, and that's it. Just one more comparison without any swaps needed, and that's it. So as you can see, the more we progress, the less time we need to actually compare, right? Because the greatest cactuses are already at the end. And I'm going to show you that in the farm. So I'm going to reset, and I want you to notice very carefully what is happening. Notice how on the first iteration, so I'm going to do this, okay. So I swapped, this is the biggest cactus, I believe, right here. So notice how, or actually the biggest cactus was the one at the top. I'm going to be clicking this, clicking this, clicking this, clicking, see, the problem is that the biggest cactus hasn't come up yet. So notice that, and now it checks, it finds that it's the biggest. This is not gonna be a problem, especially when we have the, okay, so notice now how we have the largest cactus already at the top. But to make it more efficient, sorry for the clicking, to make it more efficient, instead of going range world size, we will do -1 minus I. Now, this is something that's a bit complicated. I have a video explaining bubble sort. I highly recommend that you check it out. It's not easy to understand on just for the naked eye. Let's first of all talk about the n-1. So the last element does not need to be compared with anything after the last swap in the loop. Why? Because as we've seen right here, if I go back to the start, in this case, I mean, we were very lucky. Let me set the 9 right here and set this as a2. It was a2, correct? So run. Okay, so notice how, or actually let me count it with you. So how many times we are making comparison. So every time we see the blue, there's a comparison. So 1, 2, 3, 4, 5, 6, right? So 6 times, but keep in mind we have 7 numbers. So the world size is 7. The world size is, well, in this case, yeah, it's a bit different. In this case, the world size is 6. I'm going to remove one of these to make it extremely clear, right? 0 to 6. How many comparisons? We have 6. World size is 6. How many times are we comparing? 5 times. 1, 2, 3, 4, 5. And that's it. The last number is at the end. No more comparisons. So we have a 6, size of 6. We're comparing 5. That's why we have a -1. And why do we have a -I? Because after each pass, right? After each pass, the largest unsorted element moves to its correct place. So notice that every single time, now the 6 is gonna move to its correct place. And that's it. So we don't need to do this extra comparison. I've showed you that, right? So now the 6 is at the end and it works. And that's why we can also add a -1 and -i. -1 removes the last comparison and -i removes every single time we swap it. And again, this is hard. This is not easy. I highly recommend that you go through it, you search bubble sort, you watch the video that I've recommended, and that you just leave any questions that you have in the comments below. In the meantime, I have a challenge for you, and the challenge is going to be to sort out the entire field, which is a hard challenge. So I want you to modify the sort cactus columns to repeat for every single column. So far we've only been solving a single column. You need to figure out a way to solve all the columns. After sorting a column, move east to the next column. Make sure that the drone resets to the bottom before sorting the next column. So keep that in mind. This will be very important later on. Repeat until all columns are sorted. And that's it. Pause the video right now and go do the challenge. Hey, welcome back. So we need to sort out all of the columns. So far we've been using these two to sort out a single column. So for column in range of the world size. I'm sure that some of you are very confused but by what we're doing right here. So questions are encouraged and highly encouraged. I highly recommend that you ask any questions that you have of me. So now we don't need the test planting anymore. We can actually start the initial planting and look at what we will have. Main. Oh, sorry, I forgot. The column right here. Boom, 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 boom. Look at that. I'm gonna speed up the process a little bit. All right. So as you can see, something very bad is happening. This column is not sorted. Neither is, I mean, this one might be sorted. This one is definitely sorted. The first one, definitely sorted. Second one looks like it's sorted. This one is definitely not. Neither is this one, neither is this one. Let me show you why. I discovered this as I was making the program. So I'm going to let it farm and I will pause. So I'm gonna be clicking, boom, 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 boom. And notice it moved east at this point right here, which means that it kind of ignored a lot of the cactuses. I mean, look at that. Look at that. It ignored this cactus right here. And that is a big no-no. So before I'm gonna actually, what I'm going to do is before we move east, and this was part of the challenge, I told you that we need to make sure, right here, make sure that the drone resets to the bottom before moving to the next column. This is very crucial. So right here, I'm gonna make sure that before we move east, that we reset to the bottom. Now, unfortunately, there's no way for us to actually put the drone on the bottom. So I'm going to have to create a while loop. So while get position on the Y is different than or equal to 0, I'm gonna move north or south, it doesn't matter, but I just imagined maybe this is not the optimal way, but I just wanted to find it quickly. So now let me clear and now let me show you. So right, we're getting the position while it's different than 0, which is the first row right here. Keep doing it. So now, hey, so I figured out what the problem was. The problem was that this move east should be, so the indentations are super important right here. So the move east needs to be on the same indentation, or it should belong to this column right here, because every time we finish a column, then we move east. Okay, so as you can see right now, all of these are sorted perfectly. Keep in mind the columns. Now we need to sort out the rows. And again, if you want to do a challenge for yourself, you can just create the rows on your own. But what I'm going to do is I'm just going to define sort cactus rows. I'll just copy all of this, paste it right here. So this is going to be almost exactly the same. We'll just change the name of variable from column to row. And in here, world size, everything should stay the same, except for this time we're measuring to the east, right? And we're swapping on the east. Then we're moving east, and we're checking if the position on the X is different than 0, and then we're moving. We are moving. Where are we moving? Where are we moving? If the position on the X is back to 0. Oh, while the position is different than 0, yes, we're moving east, and right here we're moving north. So I'm also going to be calling this sort cactus row inside of the actually I'll just create a define a sort cactuses, which will pretty much just first of all start with the sort cactus columns, sort cactus rows, and then right here I'm gonna sort cactuses and harvest. And let's see if this actually works. I mean, we've wrote a lot and I was very confused throughout this process, but this should be working. Let's see. So as you can see, we are initially planting, and then we sort out the columns. We sort out. All right, there we go. So we're sorting the rows now. Let's see. This looks good. This looks good. I'm very, very excited to see what's gonna happen. Let's go. Let's go. So what should happen is now, once we get to the end, we should just do one harvest and everything should disappear. And we should get a lot of cactuses. So unfortunately I paused. I think if I press this button, it will just start over. Please don't. Boom! Look at that! One hit, we got 1.38. How cool is that? Come on. That was amazing. That was amazing. I'll put it all in a while true. I'll run it and I'll come back to you. Hey, by the way, I made a small change right here because I noticed on my second try it wasn't planting them again because of this condition right here, if can harvest. What I want to do, actually I would like to just remove this altogether. I don't feel like we need it at all, especially on the second go through. But anyway, what you can do is just remove this if ground type equal to soil, till, whatever. But anyway, look at that. We have a perfectly working algorithm. And again, any confusion, you can let me know. Now we have the speed upgrade, boom, and now our drone is faster and things are moving very quickly. Ladies and gentlemen, I've done my best. This was a very hard video to prepare for. This was a very hard video to execute because of so many advanced things that we're doing with unpredictability. It's hard to code in these little files on the game, but I'm doing my best. I'm getting a lot of views, I'm getting a lot of watch hours, which means that you're enjoying this content. I hope you are. I'm enjoying making these videos a lot, even though they are very hard. I love solving these puzzles on my own and then creating systems to teach you the challenges. I hope you're doing them. I hope you're following along. This was a very long video. We're at the 1 hour 12 minutes straight. I haven't taken a single break, and I want to thank you for watching. Leave a like if you enjoyed. In the next video, we're going to be continuing things, so I'm gonna put a video somewhere around here, maybe 2 videos, who knows, that you can watch to proceed and go forward. Thank you for watching. I appreciate it. I'll see you in the next one. Bye bye for now.